the note, not the recording though.
Okay, you went through the note. Okay, can you give me an example for a complex number whose real part, let me write it words, whose real part is 3. Give me an example for a complex number whose real part is 3.
3. So real part is 3, yes, yes. So which means the part is 3. Complex number. Then that would be real part 3. So which means 3 plus I.
Say that again.
3 plus I.
3 plus
I.
3 plus I. Very good. Can you give me another example?
Okay. 3 minus 2I.
Very nice. Another one.
That would be 3 plus 79.
Very good. One more.
3 minus 3 over 2I.
Very nice. I like that example because you're giving me like so. So it's clear to you, right? Any complex number can be written in the form a plus bi. A is the real part, b is the imaginary part. The numbers a and b are two real numbers. So here your real part is in all of these numbers is 3. What's the imaginary part of this number? What is the imaginary part of
1.
this number? Very good. What's the imaginary part of this number?
So it should always be in plus that form. So minus 2.
Very good. What's the imaginary part of this number?
17.
What's the imaginary part of this number?
Minus 3 over 2.
Nice. Very good. I don't see then why you found number 9. Oops. Number, what am I doing? Number 9. 5. Oh, come on. Okay. So, I was thinking about this, why you were finding this hard. And then I thought of talking about this analogy between the XY coordinate plane and the complex plane. Maybe if I quickly just show you now, others, I hope you will bear with us until I clear this confusion to Nathan. I'm showing a similarity, an analogy between, because you're familiar with the XY coordinate plane and identifying a point on the XY coordinate plane using a pair of coordinates. The complex, this is your XY coordinate plane. They are very similar, right? And this is your complex number plane, complex plane. On this you have real numbers, on this you have imaginary numbers. In the XY coordinate plane, if I ask you to show me all the points described by this equation, x equals 2, show me all the points whose x coordinate is 2. That's what I'm saying when I say x equals 2. This is actually an equation of a straight line. You know that. Which straight line is this? Nathan, quickly. Now, this is useful to others as well.
Miss, can you repeat that, please?
Can you show me the line as this equation, x equals 2?
X equals 2, so which means...
I elaborated what that means. When I say...
So basically from 2 onwards.
Listen to this too. When I say show me the straight line. When I say that, I'm already giving you a hint. I'm telling you that it's a straight line. When I say show me the straight line whose equation is x equals to, is the same as saying show me all the points on the xy coordinate plane whose x coordinate is 2. The two instructions mean the same thing. Can you show me?
Let's see. Yeah. You missed like I missed it. This thing has to work.
This is O level, like grade. I don't know, where do you do this first? Grade 8, 9, I think. Yes, good, Nathan. Your start is good.
So which means there's 2. So which means all the complex numbers which has the 2. So which means
this is not the complex plane. This is XY coordinate plane. I want to show. Very nice. Very correct. Because if you take any point on this line, its x coordinate would be 2, isn't it? Isn't it, Nathan?
yeah.
Is that a difficult concept?
And no.
Can you show me y equals 3?
Okay. Now y equals 3. Y equals 3 line.
What that means is show me all the points whose y coordinate is equal to 3. When you try to show all the points, you get a straight line. Very nice. Can you draw that again? That is y equals 3 line, because for any point on this line, the x coordinates are different. We don't care what the x coordinate is. What is our condition? Y coordinate must be 3. So because this is parallel to any point on this line is parallel to that y equals 3 point, the y coordinate is going to be 3. Now come to the complex plane. Now come to this. Now come here. I tell you, show me all the complex numbers whose real part, whose real part, this is how I write this. What does that mean? Real part of z. Z is a variable complex number. Can be anything. Show me all the complex numbers whose real part, whose real part is 2.
Whose real part is 2.
Yes.
Show all the complex numbers whose real part is 2. Well, all the complex numbers whose real part is 2. Same as this. Same as x equals 2.
Can you show me in the complex plane?
This is the xy coordinate plane.
Here, in the complex plane, in the second diagram. In the second diagram, you have the complex plane, the numbers, the plane where all the numbers live. This is now when I say like that, it sounds like they actually live somewhere. I hope you understand what I'm trying to say. This is just a visual representation of our numbers. Yes, where this is 2, right? Now you have to mark this even here. Because this, what is this number right here? What is this number, Nathan? Let me mark some. What is this number right here? Nathan, now you have to quickly communicate with.
Where, miss? Where?
Yeah, Nathan, here.
Are you pointing at the number, miss? Because I can't see the mouse moving. Now it's moving. Yeah.
Wait. Here, I will write it in red. Right here, this one. What is this number?
Miss, are you pointing at the screen? Because I can't see where you're marking.
Do you see the mouse?
Yeah, I see the mouse. Okay.
Okay, now follow it right here.
Yeah, the mouse is stationary. It's not moving.
That's the point. I want you to tell me what number is sitting.
Oh, what number it is? Okay. Okay. So that would be if I'm given. So I can guess that, no, miss. That's 1, 2, 3.
Not to guess now. You have drawn this line, or you told me that
Yeah,
this
3.
line.
That's real root 3 and imaginary.
Nathan, listen,
Yeah.
Nathan. You said that this line represents
Yeah.
all the numbers whose real part is 2. Did you
Yeah.
not say that, right?
Yeah.
You
Okay.
drew this line, right?
Yeah.
Now I'm asking you what this number is right here. This number.
2. 2, 2, 2, 2, 2, 2, 2, 2.
God, Nathan.
No, miss, because what's this? In my
This,
screen, your
okay,
mouse
what
is
is
stationary.
this? What is this? What is this point? What
That
is
point,
this number?
that is 3, 2.
I have given you the units.
Still 2.
This number is so there are 2 points representing the number 2. And that is also 2. How can that be? That is not possible. What is this point? What is this?
2 plus I. 2 plus 1. 2 plus I.
2 plus I. What is this point?
That is 2 plus 3i.
2 plus 3i. Okay. Right. Is this clear?
Okay. Yeah. Okay.
So for all the numbers, now you gave me this. You said this is 2 plus 3i. These are some examples. 2 plus I, and this is 2. If you take any number on this line, it would go 2 plus or 2 minus 2. It will start with 2. That's why that line represents this little equation. If you can say, you can call it an equation. Real of z equals 2. Then similarly, can you show me all the complex numbers whose imaginary part is 3? Whose imaginary part is 3?
All the complex numbers whose imaginary part is 3, right? So which means that will be 1, 2, 3. And 10.
Very good. Right? Because this is 3i. So for any point on this line, if you read that number is going to have an imaginary part of 3i.
Okay.
Okay? Is it clear to you?
Yeah.
Now look back at example 9, please, Nathan. See whether it is clear to you now. Number 9.
Yeah. Now I understood how to do that.
Okay.
When you mean by the mod of that complex plane equals 3, that means the distance between each one is 3, right, miss? So which means if I'm taking in a specific,
the 10th one, the modulus, show all the complex numbers whose size is 3. Means who's sitting 3 units from the origin. That's the meaning of that. Nathan, you have to erase this. I can't erase this because these are your.
I'll erase them.
Okay, thank you. So I will again start with number 10. And I thought to do something like this. My next 3 examples starting from number 10. 10, 11, 12. Actually, I in my original note, I don't have what I'm planning to give you. Just I thought this might be, why does that happen now? Number 10, we already did this. Give me a moment. to shape of. Okay. We did this one. Okay. We already did this, right?
Miss, so if I'm going to
Yes.
illustrate that, Miss, was this for any versus complex number, or for any complex number versus it, that thing has to be 0, no? The size? No, has to be 3,
Yes.
So
Yes,
which means
ma'am.
it can be, okay.
So wait, I can you just tell me whether we already did this or not, please? Have we
We did
already
this.
written this and we have done this, no? But I'm just going to give it to you again. We did. Thank you, Marit. Because I'm writing, please copy this again. You put number 10 again. What this means in words, the meaning of this is all points that are 3 units from 0. 0 means the origin, right? And if you think about it, all the points that are 3 units from 0, that's the definition of a circle. Show me all the points that are some distance away from a fixed point. That's what you get is a circle, right? So any equation of this form is a circle whose radius is, so I will write that here. This is a circle with radius 3 and center. Where is the center? Now you already drew this. Where is the center of this circle if you draw it?
Origin. Origin, right, Miss?
Huh?
It's the origin, right, Miss?
It's the origin. Very good. Yes. So you get this is where your 0 is. If this is 3, it is -3, and that would be 3i, and this would be -3i, and you would get a circle. I will try to do my best to draw a nice, you get this circle, right, whose radius is 3 and center is at the origin. So this is the example we did. Now I thought of doing 2 more. Sorry. Please copy this. I'm going to fit 3. I don't know how wide your books are. 2 more. Sorry. My number 11 example, right beside it. Okay. If I say Z is less than 3. So I will write you the 3 examples I'm going to do. Then number 12, is Z is greater than, oops, I can't write there, greater than 3. How would these look like?
Okay, so means that means less than 3 now. So which
Yeah.
means the radius will be less than 3. So which
Yeah,
means
what kind of a thing would you get when you show it on the, like this visual? How would it look like? Now here it's just this circle. That means circle means your points are on this circle. Let's show some points, some numbers who satisfy this. You are right, Hatvi. Who satisfy this condition? Any number sitting on the circumference of the circle, right? For this number 10 example, your numbers are sitting right here on this, on the circumference. Okay. Where are all the numbers who satisfy this condition? This condition.
it's inside the circle.
It's inside the circle. Very good, Nathan. So if I just write it in plain language, what this means is all points that are less than 3 units. So closer than 3, right? Less than 3 units from 0. So what are you going to get? You're going to get the interior of the circle, the interior. What that means is you get the interior of the circle with r equals 3 and I didn't write the center 0 here, and center 0. Right? So if I do that, if I draw that, how hard is this? Maybe I should have just. Sometimes I feel like this is a nice tool, but it's actually can be very annoying. Okay. So you're going to get 3 here, minus 3 here, 3i here, minus 3i here. Would you get points on the circumference of the circle?
Yes.
No, Malit. I haven't said that they can be equal to 3. They have to be less than 3.
You have to draw the circle, right? First.
So you have to draw it with a dotted line because the numbers cannot be on the circumference. Because if you think of a number on the circumference, the distance would be equal to 3. But I don't have the equal. If I gave you an equal sign like that, then you can draw the circle with a solid line. But now you can't. It should be a dotted line. You draw the circle with a dotted line and you shade inside of it. You shade inside of it. Like that. Is this clear? Can you try to do number 12? Write the meaning, write what it gives you. I have written the meaning in purple. I have written what it gives you in pink or like red. And then can you draw it? Number 3. Hatsi, what do you mean? Can you show number 3? Oh, you can't see it? What? Which number 3? You mean number 12? Oh, you can't see it now? Okay, right here. All points that are what? That are more than. Three units from 0. That is what? That would be what? It should be all of the outside. So the points have to sit outside the circle. Can they sit on the circumference? No, because I don't have the equal sign in the inequality. I'm saying greater than 3. So this is the exterior. You can say the exterior of the circle. What you will get is the exterior of a circle whose radius is 3 and center is origin. With radius 3 and center 0. So you first mark out your 3 circle, the circle with radius 3. And do it with a dotted line. And you shade all of the outside. So your number can be anywhere outside the circle. Not on it, not inside, outside. So it's a region. It's a region. If I now show you all 3, how this looks like. This is just a circle. It's a line. This is a region inside the circle. This is also a region outside the circle. The first one is the circle, just the circle. It's just a line, the circumference line. Line, region, sorry. Line, region, region. Is it clear to everyone? Let me know when you are done. Okay, let me done. Maybe 2 more people when you are done. And can you just write a number 13 and leave space to complete it for homework? Less than or equal to 3. Now I'm just taking this 3. It could be 5, it could be 10, it could be 9. What should come here must be a positive number, isn't it? Because it refers to a distance. It's the size, the modulus. The modulus of a number is always positive. Modulus of a number means how far it is from 0. So it's a distance, it should be positive. So like just for comparison, I have taken the same number here, 3, but that number could be any number. Please write number 13 with an equal sign, just and leave space to complete it for homework. Okay. Can 2 more people let me know when you're done? Hatri is done. 1 more person?
Done.
Okay. Thank you, Nathan and Umalia. Number 14. Before we write number 14, I have a tip for you. Write this tip. I will start here. Okay. You might already know this, but just reminding you of this. If you have modulus of z minus some z naught. Now, when I say z naught, what I mean is it's a fixed number. It's like 2 or 3 plus I. It's a number. It's a given number. What does this little expression mean? Z minus Z naught. I mean, let's look at this with some 2 real numbers. If I say 10 minus 3, modulus of 10 minus 3, what do I mean by that? This means distance between 10 and 3. Distance between 10 and 3, that's the meaning. If I say 3 minus 10, still it means distance between 10 and 3. Okay, if you have modulus of some number minus some number, it means the distance between them. Okay, I'll make this also. Can I write Z1 and sorry, yeah, I'm just changing this slightly. Let me not say that Z1 minus Z2. I just want to give you the meaning of this. If you have a number minus a number and a modulus of that, what that means is means distance between Z1 and come on. That's what I don't like about this board. Z1 and Z2. Okay. So in this example, this is 7. This is also 7, right? It doesn't matter which number is being written first. When you put the modulus sign, it just gives you the size, the distance between those two numbers with a minus sign in the middle, okay? So just write that tip. And then let's go to number. Which number do we have to do now? Number 14. After the tip, you put number 14. Here's number 14. Modulus of Z is my variable number. Okay, Z represents any complex number. Z minus, let me say Z minus, let me take a purely real number like Z minus 2. Okay, I say that must equal 3. What do you think you will get here? Now I'm going to give you, just like before, I'm going to do 3 parallel. In the 15th one, I would say Z minus 2 is less than 3. And number 16, Z minus 2 is greater than 3. How would these 3 look like? Let's translate this into simple language. Now you know what this side means. This means distance between Z and number 2 must be equal to 3. What I'm saying, oh, where did everything go? This is the, it is such a pain. Maybe I shouldn't have started to draw in this. I should have stick with the Zoom whiteboard. This means all points what do you mean by that? So that means like just 2 numbers satisfy this condition, only 2 numbers? This means all points that are 3 units from what? Earlier, look at this one. This is all points that are 3 units from 0. This means all points that are 3 units from this number 2. All points that are 3 units from number 2. The distance between 2 and Z must be 3. All points that are 3 units from 2. Is that right? Can you think about it? Did I translate this symbolic expression correctly into simple words? Is this what it means? All points. When I say all points, that I'm referring to Z. Z represents any point. So what points are these? Points that are 3 units away from 2. because the distance between Z and 2 must be 3. So all the points who are 3 away from 2. What does that give you? It's a, again, it's a, can you try it? Can you think about
Circle.
it? Huh?
Circle.
It's a circle. It's a circle. How did you write this here? A circle with radius 3 and center where? At whatever this number that you have here. What number do I have here? 2. And center must be 2. The point 2. The number 2. The center is the number 2. How would you draw that? Say 2 is, actually I need to move this way. Because I need, okay, so this is 1 and this is, it's too close. So this is 1 and this is 2. Okay, so you find where 2 is, that is going to be your center. This right here is going to be the center of your circle where 2 is, and then the radius 3. So this is a big, okay, I should reduce this even more, wait. Otherwise I can't fit it into my 1. So this is 2, okay. This is my center. Still, it's going to be a little too big. So what points should I, so this way 3 means up to here where -1 is, and on this side up to 5, isn't it? And then here up to 3i, and down here up to -3i. I mean, so this one. I'm trying to do a circle with center 2 and that. The radius of this is 3. Do you understand this? What you need to understand is that this symbolic little equation I have written actually represents this. Do you see that? And I am like writing this in words, and then that way for you to help understand that. So if you if you think about this, take a point on this circle. Okay, let's take a point. Let's take some. I'm not going to read what that point is. Just take random. Just take a point on that circle. Look at this point. Now this is a circle. Now, do you all agree that the distance from this number 2 to that point is 3? That this distance is 3? Do you agree? Take another point on the circle somewhere here. We don't need to read what that point is. Whatever that point, isn't the distance from that point to the point to this middle point, which is at 2, is 3. Do you see that? Can you verify? Can you verify to yourself like that? If I take some points over here, if I take some point over here, yes, point means I'm taking a z, right? Some z here. Then the distance, no, this is actually, I don't like this. I'm gonna, this is 3, right? And that's why you get a circle. 2 is a fixed number. 2 is fixed. I'm saying, look at number 2. Can you show me all the numbers who are 3 units away from 2? So they all are on a circle. Is this clear? I still didn't get a response from you that this is clear. That's why I'm trying to, I'm constantly repeating. Clear. Okay, thank you, Nitni. One more person? Why here today? Let me check your list. Here, no? What has happened to Bimandi? Bimandi has not been attending class. Did anyone hear from Bimandi? I should drop her a message. Okay, then can you try to do number 15 and 16 on your own? I'll give you 5 minutes. You have to write these two, okay? So it's like a little note now I'm giving you. Now, when you have to do it in the exam, you don't write that. I have just written these 2 little statements in 2 different colors for your understanding. So can you complete number 15 and 16 on your own? In 5 minutes. Now, another thing, when I say all points, remember a point represents a number on this plane. So I'm showing you all the numbers. That are 3 units from the number 2. Here, less than 3 units from number 2. You will mark number 2. Oops, it should be a dotted line. You can do a proper circle with but you can use some tool to draw a circle. And then shade the inside. And I can mark the radius of the circle is 3. Center is sitting at 2, the number 2, the point that represents number 2. Let me know when you are done with number 16 as well. Okay, Umalia. 2 more people. So this means if you have a restriction on the modulus, any equation or an inequality given to you with the modulus, inside you can have your variable z minus, it could be plus also. We'll see if you have plus how you can manipulate it. Whichever way it is given, if it is a modulus involved, it's going to be something to do with a circle. It could be just a circle, it could be the interior of the circle, it could be the exterior of the circle. So, something to do with a circle. Okay, so 2 of you are done. I hope I don't have to show you number 16. It's the exterior of the same circle whose radius is 3 and the center is at 2, right? Now, if you understood up to here, I'm going to give you 3 more, not 3 more, a few more, okay? All is practice. Now, you don't have to keep writing these. You don't have to keep writing these. I will give you a condition. So just continue the numbering. I will give you a condition. You just quickly do me the sketch, the illustration, okay? This illustration, you do me the illustration. Is it clear what you have to do? I'm going to stop sharing this and I'm going to use the Zoom whiteboard. Oop. Zoom whiteboard. Yeah, I think I like this better. So I will start with number 17. Continue your numbering. Here's your number 17. You have to do this quickly, okay? Just the sketch, just do me the sketch. Can you show me Z minus 2i is equal to 2. And then number 18. Z minus 3 plus 4i is equal to, is less than or equal to 5. And then 19. Z plus 3 minus 2i is equal to 3. And number 20. Z plus I is greater than or equal to 2. Can you just sketch these 4? All these have something to do with a circle because they are all about, it's either an equation or an inequality. The condition involves an equation or an inequality with a modulus. If you see the modulus, you have to know how it's some circle. Okay. Equals means it's the circle, less than some, less means inside, greater means outside. I mean, don't memorize it that way. But I hope after you understand it, you can it'll just come to you like that. And for all of these, this is the radius of the circle involved. This is the radius. That number is how much the radius is. And this number is where the center is. Here you have to make a change. I will not tell you because it is plus here. Here also plus. So you need to first rewrite them. so that you have z minus, because you can only interpret a number minus a number and modulus of that. You can only interpret that as a distance. If you have a number plus modulus of a number plus a number, we don't know what that means. But modulus of a number minus a number means the distance between them. So if you have plus, you have to rewrite. I mean, you can write it. You can write the same thing with a minus there. So you think about it. I'll give you a few minutes again. Let me know when you're done. Let me know in the chat if you're done, or if anyone can do, you can draw on the screen and show me what these illustrations are. Okay, Hatvi says done. Shall I do the first one? Hope everyone is done with the first one. Okay, so the first one. No, I don't have enough space there. Shall I go to a new page and do it? Z minus 2y. So this is number 17. It's equals to 2. Okay. So what you have to do is you draw your grid. Label your axis. First mark this guy. Mark that, locate that number. Where is it? Somewhere here. This is just a sketch. You don't have to draw all the scale, and you don't have to do any fancy stuff. Just mark the point where this number is 2i. So it has to be on the imaginary axis 2i. And then you have to draw this is equal to 2, right? So it is exactly the circle whose center is at this point 2i with a radius of 2. With the radius of 2 means, it will exactly pass through the origin and up here like 4i. And then like just if you mark the 4 points on the around it, it's easy for you to draw it. Then you draw the circle. It's a circle. It has to go through nicely that point like that. So that the radius of this is 2. Did you get that? It has to pass through the origin here, because from 2i to 0 is exactly you have 2 units. So things like that has to be accurate. So this line, the curve, the circumference of the circle, the number sitting on it satisfy this condition. For all the numbers on this line that I have drawn, the distance from that any point on this line to the number 2i is equal to 2. Clear? Got it? Number 18. That's 4i. I'll go to a new one. Number 18. Z minus 3 plus 4i. Now again in this one, I have properly given you in the format. You have Z, you have minus, and I have even nicely bracketed my number. 3 plus 4i is what? Is less than or equal to 5. Less than or equal to 5. Anyway, I have to start with a circle. So you first draw your grid. Label your axis. Don't forget to label your axis. Big trouble if you don't. Then mark, locate that point. Where is 3 plus 4i? Roughly, in which quadrant? The first quadrant, surely, right? 3 plus 4i. Coordinates 3, 4. 3, 4. Say it's so 3 units here. Oops. If I take a lot like that, I will not have enough space. Say this is 3 and this is 4. Then my 3 plus 4i point is right here. Find that point. Okay. This is 4i. This is 3 plus 4i point. 3 plus 4i number is sitting in that point. So that's where it is. Now I have to draw a circle with radius 5 with center being that point. So you have to like know whether it will cross over to this. So this distance is 3. So it will be like that much to either side of here. This distance is 4. So it will go below the that is 4. Your 5 would be like up to there and up to there. So the circle. Hope it'll be okay. That's not very nice, but well, this is 5 units. You mark the radius. Oh, so is it a solid? Should it be a solid line? Equal sign is there. So it is a solid line. And then you shade the inside. So your point can be anywhere inside this circle. It can be on the circumference or inside, because it can be equal or less than. So this is your number 18 illustration. Is it clear? This point over here, if I just show you, this point is what? This is 3 plus 4i point. 3 plus 4i number. Then number 19. Who can tell me how you need to change this as it is given, the way it is given? You can't straight away go to the illustration. You have to first rewrite it as, can I write it as z minus something equals 3? You have to write it like that. Otherwise, you can't make sense of what that means. So the same inequality z plus 3 minus 2i can be written as z minus what? Z minus which number? Hello? Two I? No. Not 3.
Miss, so we should make it minus now. So which means that is minus 3.
Very nice, huh? Very good.
Minus 3. Plus 2i.
Very good. Minus 3 plus 2y. That's where your center going to be. At the point where that number is sitting. Minus 3 plus 2y. Okay. So that's the one I'm going to write. Z minus. Which number is that? Number 19. Z minus 3 plus 2i. is what? Equal to 3. Equal to 3. Okay, it's just a circle. Equal to 3. Now you can draw it. Draw the axis. Label the axis. Find where this point is. -3, 2i is in the second quadrant. -3, 2i. Coordinates are -3, 2. -3, 2. So it would be somewhere. If this is -3, if this is 2i, it would be right here. That's the center of your circle. And then you would take your pair of compasses if you have, keep one point on that point, open it to 3 units, I mean 3 units in your grid, and then draw your circle. So 3 units means it will exactly pass this point this way. I hope, because this distance is 3, so it will pass this point. It has to go below the this thing here, somewhere here, somewhere here. So if you keep those, if you mark the 4 points above, below, left, right, it's easy for you to complete it. And then it's equal, so it's just the exactly, oops, that's ugly. Like that. I'm sorry, my circles are bad. And the radius is 3 units. So it exactly like, it's a tangent to the y-axis at 2i. It touches at 2i. And it goes below here by 1 unit. Because this distance is 2, I need 3, so 1 more down here. So just check like that, and this is your sketch. You don't need all the details. So it's the circle. It's not a region, it's the circle. It's the line that I have drawn. It's all the points or all the numbers on that line. So similarly, you can do the last one. You have to first rewrite it as z minus what? Z minus what? Z minus minus I. Minus I. Oh. Okay, so everything is Z minus I. Z minus minus I. Z minus minus I greater than or equal to 2. So oops, you draw your axis. You label them. Don't forget to label. Find this number, minus I on the grid. Find it. Minus I is right here. So this is minus I. That is your point. That is your center point. That's where the center is. And now a circle, and this is the exterior of that circle. But let's first draw the circle. And do you draw the circle with a dotted line or a solid line? Solid line, because you have the equal sign. Your numbers can be on the circle as well. So you draw a solid circle with the radius 2. So it will go above the real. So because this is just 1 unit, that should be another 1. And then, so roughly you can just keep a point here, keep a point similar, like the equal length. And then, oh, that's and then you Shade what? Shade outside, isn't it? Shade all the outside. Outside, carefully shade all the outside of that circle. Like that. So your numbers can be, this is an infinitely, there are infinitely many points that satisfy this condition. Is it clear? Is it clear to everyone? You've been very quiet. It's very boring for me. I feel lazy.
Yes, it's clear.
Thank you, Nathan. Okay. We have one more thing. I have an interesting. I have never seen I have never seen examine in a past paper this being there, but I would like you to try this. So add this as the next one, number 21. I will write it here. Number 21. Do I have it written here? Something like this. How this will look like? Okay. I don't have it here. I don't have it here. It's okay. This is for your own it's for your brain. Okay. Z minus. I'll say any number. Put any number. What number do you want to put here? Put any number. I don't care. I'm going to say greater than 2, but less than 5, like 2 inequalities. What kind of a thing would you get here? This is really interesting to think about. Put any number you want. What number do you want to put? Let's put an easy one. Let's put, what do you want to put? A purely real number, purely imaginary number, or both, mix of both, anything. What do you want to put? You're not saying, so I will say 3i. Try this at home. You are already at home. Try this for homework. You take your little, here, sorry, Mihila, I'm just seeing your number. I'll give you a small break. Just walk around, take off your eyes off of the screen. Be back in 5 minutes. One more little set we have to do under this. And then we are going to look at the last topic in complex numbers and finish this off. Okay? 5 minutes. Take a break. Hello, I'm back. And Mihir has given me what do you get for this? And Mihir is right. So I will not say it out loud. Mihir, well done. Yes, that's what you get. Something of that shape. Yes. So for anything that looks like double inequality, now I said if you have a modulus, it's to do with a circle. A double inequality. So you think what that is? Okay, number 22. So far we looked at conditions conditions imposed upon the real part of the complex number, conditions imposed on the imaginary part of the complex number. They both are lines. Then the last set of things that we looked at were conditions imposed on modulus of the number. The next set we will see conditions imposed on the argument. But if I say, show me all the complex numbers whose argument is equal to this or whose argument is less than this. Remember, argument is an angle. It's the angle made between the line connecting the origin, point 0, and your complex number, and the angle made between that line and the positive real axis, right? So I can say, show me all the numbers for which that angle is equal to 40 degrees, something like that. Okay, so let's look at a bunch of that type of subsets of complex numbers. These are all subsets of complex numbers. So number 21. Number 21. Can you illustrate on the complex plane all the complex numbers whose argument, I will start with an equality, is equal to pi by 4, that is 45 degrees. Can you try this on your own? All the complex numbers whose argument is pi by 4. Let me know when you are done giving it a try. What do you get? Are you trying or can you talk to me? So if you have no clue how this should work, just take a random, okay. Let's try to find one such complex number who has an argument of pi by 4. Like if I pick something here, let's think of this particular, this one right here. What's the argument of that? I mean, can you show me? Not tell me the amount, you can't. Can you show me the argument for this complex number? What do you mean by argument of a complex number? You first have to draw the line from 0 to that number. And then argument is, it can be either measured as a positive angle from the positive real axis this way, or a negative negative angle. Okay, so that's the argument, that angle. So I want that angle to be how much? 45 degrees. So is my choice of, can my number be here? No, that's not 45. This is greater than, this is a positive angle. So I have to go this way. I have to go anti-clockwise, and it should be just 45. Okay, Hatvi says first quadrant. Good, Hatvi. Where in the first quadrant? So for example, who can keep a dot on the screen, annotate and keep a dot on the screen to show me one such number whose argument can be pi by 4. So the angle made between the line joining that point and the origin and the positive real axis must be 45. So show me one such number. Yes, Hatvi, you are right. Not completely, but you're on the right path. A number somewhere here, like here. Would these be okay? No, they make an acute angle. I mean, 45 is also acute, but this is less than 45. I need you to talk to me. I don't know what you're thinking. Okay, then I will spoil your thinking. I will just spoil your thinking and take away the opportunity for you to think, and I will just say it because you're not talking, and then I don't know how to do it. If you don't talk with me, I can't. So that this means any point on the line, it has to make 45 degrees now. So it's going to be a line. Can it be a point this side? No, then the angle is going to be something like that. It's greater than 45. So not those points, only the points in the first quadrant who will make a 45 degree angle when you connect them with the origin. So you're going to get all the points on this line, the diagonal line, up to, can you come all the way up to the origin? Does this point count as well? Does 0 count as well? It can be any point into that direction. You can't continue this line into the third quadrant, then that is wrong. But my question is now, would you include 0 as well, or should 0 be excluded? What's the argument of 0? Exactly 0. What's the argument of 0? Yeah, no 0, because the argument of 0 is, what is the definition of argument? You have to connect the point to 0. You have to get that line and the angle that line makes with the positive real axis. If you think of 0, 0 doesn't make a line when you connect 0 to 0. It has no line. So 0 doesn't have an argument. 0 is the only number that has no argument because it doesn't make any angle with the positive real axis. No angle made. So you have to exclude I mean, like this can go that way. You have to keep an open circle here to say that 0 is excluded. Okay. That is your illustration. So it's a straight line. It's only the points that are on this line that are sitting on this line. It's a line where you can mark this angle where this is pi by 4. Okay. Number 22. Argument of Z is less than or equal to pi by 2. Now, this is an inequality condition imposed on the argument. The argument must be less than or equal to 90 degrees. Where can your numbers be?
It can be from 0 to pi over 2. Yes.
What do you mean by that? Yeah, what does that mean? What is it a straight? Is it a line? Is it a region? What is it? Is it a circle?
So which means it can be the angle the argument can be either less than pi over 2, or it can be pi over 2.
Yes. So what is that? Can you show me? You're just telling me what this
Yeah. Sorry. I'm really sorry. Give me a second. Hold on. Wrong. That's wrong. I think
pi by 2 is 90 degrees. Okay.
Sorry. I'm really sorry. So which means it's the whole thing over here, I guess. This whole side.
Very good, very good. But it's better if you can be more clear and since it's. I hope you all can see that it's the whole of the first quadrant. But do the lines include? Like you have to think everything. All the points in the first quadrant will come. That's correct. What about the points on the imaginary axis, the positive imaginary axis? Are they included? Then you have to draw a line there to show. What is the boundary of this region? You have to mark the boundaries. First, let's mark the boundaries. Any point on the imaginary axis, I will draw with red. All these points will come. All these points will come except 0. You have to exclude 0. All these points will come except 0, because for any point on this line, argument is 0. For any point on this line, argument is exactly 90. And for any point in between, argument is less than 90. Okay, and then you very clearly shade it. Shade the first quadrant, but you have to show the boundaries. Please notice how I started with the 2 boundary lines. If you don't draw those 2 lines, your illustration is incomplete. You will not get full marks. So the 2 lines have to be there, and 0 has to be excluded, and the first quadrant must be shaded. Clear? Clear, everyone? Can we go to the next? Okay.
Okay.
Oh, who's Oshadi?
Karindu.
Oh, that's fine. Number 23. Can you try this one quickly? Okay, now we have to hurry up. It's 8 o'clock. We have only 1 more hour. Argument of Z is how about between 0, and pi by 4. What would that be? Oh, let me remove the equal. Just like that. Can you quickly do that?
Miss,
Yes.
can I annotate on the screen?
Yes. Be my guest.
I think this is the answer.
Please
So
do it. I'm sure you got it.
let's see. That is pi by 4. So which means
That is wrong, Nathan. Where is
that's
it's
wrong.
like covering no, Bob. You can't carelessly do this. It has to be exact. Now see how
Yeah,
careful.
I know. But this sometimes my was this
Yeah, so
the pen it goes out.
do it carefully.
Yes, that's good. No. Why is this doing this to me? Let's see if this works now. Okay, that's better. Fine. That's
Better
what I
is
do.
not good enough. It has to be correct. Can you just tell me what you want to draw? Then I will draw it.
Okay, Miss, from the center point, I want to draw the
Origin.
yeah, from the origin. I want to draw that angle. So basically, that angle was this
But you have to exclude 0.
yeah, what we have to exclude 0. So which means that
So that's one
that
boundary.
angle that angle
Is
which
pi
is
by
between
4.
pi by 4. That side
Huh?
that in between the real axis and the imaginary axis, that's not counted. The ones around it is counted. That means the one below
The
it.
two boundaries are this diagonal line and the real positive real line. Those are the two boundaries. And then you shade
The inside. Yeah. There we go.
But one mistake. These two lines have to be dotted.
Dotted.
Why is that?
Because they are not
that
equal to that. Because they are not equal to that.
Miss Uggs is greater than pi by 4, right?
Sorry.
Yeah.
That's not what I meant. Wait, thank you, Tarindu. But that's not what I meant. Let's.
Tarindu.
That gives a ugly region. That's not what I meant. Let me change it. Thank you, Tarindu.
Let me color it.
Greater than 0. 0 here. 0 here and pi by 4 here. And less than pi by 4. So your lines will have to be dotted. Like that. And then this line also should be dotted. Is that clear? And in between, I wanted to get this, okay? Between 0 and pi by 4. Between 0 and pi by 4. So your number cannot lie on these edges, edge lines. Okay, before the next one, I have a tip. We will do like 2 more.
Miss?
Yes.
When you wrote the previous one, Miss, I thought the 0 could also be 360 because 0 and 360 are the same now. That's why. So
they are the same. If the argument is 0 or 360, that means numbers on the positive real number line.
Yeah. So that's what I was trying to draw, but I guess this is also correct.
This is the one that matches what I've given now.
Yeah. I see it.
Before number 24, here's a little tip again. You need this to do number 24. The meaning of something like this, if I have argument of some number Z1 minus some number Z2, okay? What this expression means the angle between the line connecting Z1 and Z2, the line connecting Z1 and Z2, and oops, a line, how do I write it? A line parallel to it, okay? There is a way to write it, but if I say and a line parallel to, and a line parallel to, do you hear this sounds in the background? A line parallel to the real axis, capital R, real axis. Argument of Z1 minus Z2, if I tell you, if I give you two numbers, and if I say the argument of Z1 minus Z2, it means, give me a moment. The angle between the line connecting Z1 and Z2 and a line parallel to the real axis. So for example, if you have, so take two numbers, Z1 is here and then say Z2 is here, okay? If I write argument of Z1 minus Z2, it's an angle. What is that angle? You have to connect Z1 and Z2, okay? And it's the angle, this angle. You take a line parallel to the real axis and the angle between that line and the line connecting Z1 and Z2. Is that clear? Wherever your Z1 and Z2 are, say Z1 is here and Z2 is here, then you connect them, draw a line parallel to the real axis, that is the angle. What this means? Argument of Z1 minus Z2 means that angle. Is that clear?
Kind of.
Kind of. Okay, let's take another pair of, you take any two numbers, let this be Z1 and let that be Z2. You connect Z1 and Z2 and draw a line parallel to the real axis and the angle between them, that angle.
Miss, how do we get it?
What do you mean, how do we get it?
Like,
You're not going to keep a protractor and measure it. What I'm explaining is what this expression means. If you have argument of some Z1 minus some Z2, it means it is referring to the angle made between the line connecting Z1 and Z2 and a line drawn parallel to the real axis.
okay, Miss.
Is it clear? Do you want to try? Shall I give you another new pair? Okay, I mean, you can sketch what I just drew if you need that to understand. I think you should. Let's try another. Let's try. Okay. Say you have, okay. Do you want to try? Does anyone want to try giving me two numbers, Z1 and Z2? Keep 2 points on this plane. Any 2 points. Some Z1 and some Z2. Doesn't matter where they are.
1 plus 3i.
Can you just keep a point? Annotate. Right here. Okay, I see it's Tarinder. 1 is here. Let that be Z1. Where do you want your Z2 to be? Right here. Okay, I see it right here. Z2. Then you connect Z1 and Z2. You connect Z1 and Z2. It's Z1 minus Z2 now. Okay. Then you have to draw a line parallel to the real axis from Z1. And then it's the angle between. Oops, sorry. It's the angle between. So if we go anti-clockwise, that angle. Understood?
Yes, miss.
Okay. Is it clear to everyone else? Can you please sketch those few examples that I just drew? You do some examples on your own in a little sketch to show what that means. Argument of some number minus some number means you find those two numbers, connect them, and draw a line parallel to the real axis from Z1 and the angle made between them. The anti-clockwise. Hello. Tati. I'm sorry. You have done the payment in there. Palling Gandiga. Me Nandi Bapida. Nandi Bapita Anakamani.
Hello.
Sorry. Give me a moment. I'm sorry. Sorry about that. Okay, so is this clear to everyone? Okay, so this is your tip, what this means. Now I'm going to give you a condition with this. What's our next number? Example number. Our last one was what? Number 23. So number 24. Number 24. After the tip, here's your number 24th subset. I'm giving you a condition. You have to show me the subset of numbers that satisfy that condition. Here you go. Can you show me all the numbers who satisfy this condition? Argument of Z minus I is equal to pi by 4. Z minus I equals to pi by 4. Oops. Can you try?
Miss, if we edit this way, where would Z come?
So Z can, that is what I want you to show. That is what I want you to show me. Where can Z be? Z is a varying, it could be any number. Show me all the possible Zs.
Okay.
Okay. All the possible positions for Z. Oh, wait, Z minus I. I think I made a mistake in this. Z1 minus, yes, I did. Can you, oops, I'm very sorry. I made a mistake here. Can you change this? Everything will be correct if I make this small change. This should be Z2 minus Z1. The line you have to draw parallel to the x-axis from the second number, that angle, the angle between Oh, did I confuse you now? You find the 2 points, connect them, draw a line parallel to the x-axis at the second number and the angle between those two. So the first thing you do is find I. Now that is fixed. Now let's find I. Where is I? Say I is right here. Okay. Now think of one such number for Z. Where could Z be, so that the line connecting I and Z has to make 45 degrees. Pi by 4 means 45. 45 degrees from the real axis. A line parallel to the real axis drawn at I. Okay, let's draw this also. Let's draw the line parallel to the, I'll make a dotted line. From that line, you make 45 degrees. Any number on that line would satisfy this condition. What's the line? Do you see it? What it is?
45 degrees.
Making a 45 degrees angle. Very nice. Yes. But this is very similar to the thing here is, it's not from the origin. It's from this number. It's from that number. Earlier, let me go back. Remember this? Remember this? Remember this? Here it starts from the 0. Now it starts from this number. And you have to exclude I, because if Z is I, I minus I is 0, an argument of 0 is not defined. 0 has no argument. So you have to exclude, just like you excluded the 0 in the previous ones, you have to exclude that starting place. But any number on this line, will satisfy this condition.
Miss?
Yes, Tarindu.
Miss, there is a question.
Yes.
Miss, if you are asked to shade the region of a complex number Z, where the modulus of Z is greater than or equal to Z minus 3I, that modulus.
Okay, so we didn't come to that type yet. Wait, okay, so this is about to, wait till we get there, okay?
Okay, Miss.
Shall I give another one of this type? 25, no? 25. Can you quickly do this? Argument of Z minus, let me put, I will make this bracket a square bracket. Z minus, what? Minus 2 plus I is, how about, is less than or equal to pi by, I will give you pi by 4, it's easy to draw. It's a line exactly in the middle, 45 means, right? The exact diagonal line. I can give pi by 3 or pi by 6, like 60 or 40, any other angle, but then you would have to like measure it. Okay, can you quickly do this? So first you have to find this number, minus 2 plus I, minus 2 plus I. Where is minus 2 plus I? Minus 2 plus I somewhere here. Suppose it's here. Minus 2 plus I. This is minus 2 plus I. So I first draw the line parallel to the real axis. Now the angle from there to my Z should be, so it's pi by 4, no, I'm saying less than. Okay, so let me draw the pi by 4 line. Pi by 4 line would be a line like that. Is it a solid line or a dotted line? Should it be a dotted line? Can my points be on that line? Yes, because it can be equal to pi by 4 as well. Thank you, Netni. So it's a solid line. You can mark pi by 4 there. And so this is going to be a region. The argument can be less than that. So can my points be on this line? Can my points be on this line? Can I restrict it? Can I make, otherwise it will be a little, can I also say it's greater than 0? Can I also say it's greater than 0 or equal to 0? Okay, argument is greater than 0. So between 0 and pi by 4. Then can it be on this line as well? Yes, it can. And then everything in between. Everything in between. Right? Like that. Is that clear? Okay, the
Yes,
last set, what Tarindu just asked, the last set. Now, before I come to this last set, we have done so far 4 types of regions or lines. Okay, these are subsets. 4 types of subsets. How to show by drawing as an illustration on the complex plane. How we can show a set of complex numbers that satisfy a certain given condition. We saw conditions on the real part, conditions on the imaginary part, conditions on the modulus, conditions now on the argument. The last set that I'm going to give you is again on the modulus, but 2 conditions simultaneously. This is how it looks like. And now you can tackle this if you think of the meaning. Okay. Number 26. Now, from your knowledge so far, you can tackle this on your own. Can you show me all the numbers that satisfy this condition? Z minus modulus of Z minus 3 plus 4i is equal to, usually we get a number here like 5. Instead of giving you a number, I give you this. Z minus 1. Now this looks terrifying, but if you break this down very slowly, think of its meaning. What does the left-hand side mean? Translate it into words. What does the right-hand side mean? The left-hand side must be equal to the right-hand side. If you slowly break this down into simple words, it's describing a very easy, it's not that difficult, okay? I will give you a chance to try it on your own first. My advice to you is first translate this into words. Translate the left-hand side translate the right hand side and then think about it, and then it will occur to you, oh, the points that do that, I can't say it, so. I'll give you 2-3 minutes to try. Did you try? What happened? Think of this in terms of an analogy. Think this is a fixed number now. These are fixed numbers now. Think of the fixed, oh, oops. This is a fixed number. This is also a fixed number. Think of this as a tree. This is on the ground. And this is also a tree. So there is this tree, it's fixed, a tree. There's another tree. This is I'm drawing like on a plane, right? I hope you can like visualize. This tree is here, this tree is here. This is you. You can go anywhere you want. A tree can't. Tree is fixed in its place. You have to go and stand so that, what is the condition? The distance between you to this tree, tree 1, tree 2. This is tree 1, tree 1, tree 2. What does this mean? The distance between, its modulus means distance between, whatever, distance between you and tree 1 must be equal to the distance between you and tree 2. Where can you go and stand? Just think about it like that. It becomes so easy then. There is a land, huge bare land with only 2 trees.
Miss, I think I will do.
You can do it, yes.
Miss, should we draw the two?
You have to do this on the complex plane. This is just an analogy, something that aids you to think, that helps you to think of this scenario.
Miss, should we draw the two complex number? If you take
the
line.
Show me where they are. Yes, yes.
And take the. All right.
Yes, Taridu. No. Angular. You're close. Okay, let's think about this. Wait, I forgot to. Can I write this statement in words? What this means is, what's on the left hand side telling me is, what is this? Distance between Z and this point, 3 plus 4i, must equal the distance between Z and this number. Show me all such Z points. Okay. So first, let's locate these two fixed points. Where is 3 plus 4i? 3 plus 4i. 3 plus 4i is roughly, say this is 3, say this is then 4i, then this is 3 plus 4i. This is 3 plus 4i. Where is minus 1, 2i? Minus 1, 2i. Minus 1, I could have made it bigger, but it's okay. Minus 1, 2i. Minus 1 would be like somewhere here. 2i would be right here. So this is 2i. So this would be minus 1 plus 2i. Right? Now I'm going to erase all the other and these dots and everything. Okay. Now think. So those two are the fixed ones. Can you place yourself, your Z, you're the variable point. You can be anywhere you want, satisfying this condition. You have to go and stand so that you are equidistant to these 2 points. The distances between you to this and you to that should be equal, means you should be equidistant to them. You can go and stand anywhere, but your distance to these 2 points have to be equal. What kind of a thing or a line or a region do you get? Equidistant means one, shall I show you one place where you can go and stand? You can go and stand right in the middle of them, because then you will be equidistant to both of them. Let me connect them first, like just connect them. Okay. If you stand right in the middle, right here, you are equidistant to both of them, aren't you? Where else can you be? So that's one Z. That's one possible Z satisfying this condition. Where else could you be? I need you to think. Nothing comes to your mind?
Miss, we can draw the line that if we draw a line from that point A, if we take minus 1 plus 2i as point A and 3 plus 4i as point B, then we draw a...
Malit, correct, yes. Yes, you draw a...
Okay.
Yeah, I'm sure that's the same thing that you were trying to say. Perpendicular bisector. If you think of a line perpendicular to this, passing through... it inverts, yes. Okay, a line like that. Perpendicular to the line connecting these two. So make this line a dotted line. Your line, your answer line is this. It's an infinitely long line going like that. Malit stole your Nathan's thunder. Okay, Is this clear? Think of, if you are here, do you see? You are the same distance away from B and A. You are equidistant. You are the same distance away. For any point on this line, you are the same distance away from A and B. Okay. So for this, what you get is, this is called the perpendicular bisector. What do you call this? What do you call this? This is called perpendicular bisector of what? Of the line connecting A and B. If you call this A and this B, the two trees, the two fixed numbers, it's the line connecting A and B. So the answer, it's a straight line. The answer line is the perpendicular bisector of the line connecting A and B. The line connecting A and B is not part of the answer. It's the perpendicular bisector of that line. Okay, so everything else have to be just dotted lines or drawn in pencil. Your final solution is this line that I've drawn in purple. It's the perpendicular bisector of the, of the line connecting A and B. Yes, Hatvi. Very good. Hatvi is asking, shouldn't it just be the midpoint? Shouldn't it just be this point, right? Let me remove these distractions out. Okay, so that this is very clear. Let me remove all these little other things. Okay. Oops, sorry. Here's A and here's B. Here's A and here's B, right? Hatvi is asking, shouldn't it just be the midpoint? Only the midpoint. Let me erase this also. Everything else. He's asking, shouldn't it just be the midpoint? It is only one possibility. If you go and stand in between, exactly if you visualize the line connecting A and B, and if you go and stand right in the middle of that line, you will be equidistant to A and B. But Hatvi, you can move to other position. Think of, okay, if you are here, right here, so that this distance from B to you is the same as this distance from A to you. You would still be, these two lines are equal. You would still be equidistant from A and B. You can be somewhere here. Do you see that? You are still the same distance away from B, same distance away from A. These two are equal. You can be here. You can be here. You have to be equidistant from A and B. Whatever distance you have between A and U must be between B and U. It's like a triangle. Got it now? So you can be anywhere on this line, anywhere on this line. And what is that line? It's the perpendicular bisector of the line connecting A and B. It's a good question, Hatvi. I'm glad you asked it, because I'm sure others might have had a similar doubt in their minds as well. Okay, let's do one more related to this, the same condition. Number 27. I will make it a little difficult. I'm going to make it a little difficult. Now, please pay attention to what I write. I'm not bracketing here. I have no bracket here. Can you try this? The first thing should be this modulus thing should have this form. Z, you have to have minus, and you have to have your solid number nicely. You have to have this form. If you don't have that, you have to make it. You do not have in either of the two things I have given here. So you have to rewrite this first. Before you do anything, you have to bring the two expressions on either side of this inequality to this form. You have your Z and should be a minus sign, and in brackets, you have to identify your fixed complex number, the tree, the fixed tree. Here I have not put brackets. You cannot just put brackets there. Can you tell me how it will look like when you rewrite it properly? Just do that step. Should you put that? Yeah, yes, Hatri, yes. I need to have this written 2 minus what, and here, sorry, not 2z, z minus what. Bring it to that format. Then what are the two fixed numbers? What are the two trees? This would be 3 plus 2y. And this would be minus 1 plus 2y. Isn't that the same number we had earlier? I think so. Right? Now you know this has something to do with the perpendicular bisector. But it is not equal here. It is greater than or equal. So it will be a region. It will be one side of the perpendicular bisector. You think about which side. You have the perpendicular bisector as well because you have the equal condition. You have the equality and also greater than. So carefully think about this and draw it. First, find where the 2 points are. 3 plus 2y. So this is 3. So this is 2y. Okay, so my first number would be right here. Let's call them A and B. Let's call them A and let's call this A. And let's call them. You can do that, okay? Point A, number A. You're calling it number A. Or even better if you can like say Z1, because Z represents the complex number. But it's okay, A. Where is -1, 2y? -1, 2y is right somewhere here. Oh, it's in the same level as 2y. -1. Actually, this is a little wrong. That's right here. This is my A. This is my B. Right? Now, what is the region? You draw the perpendicular bisector. For that, you needed it's a horizontal line. Perpendicular bisector would go through what? Yes, a perpendicular bisector. It should be a solid line because you do have the equality part in this. Now you have this must be smaller than that. That means you are not equidistant. You can be equidistant as well because you have the equal condition as well. But if you think without the equal condition, if this is less than that, what does that mean in terms of distance? You have to be closer to A or B. The distance between you and A must be smaller than the distance between you and B. That means you have to be closer to B than to A. You can be equidistant to both of them, or you can be closer to A than to B. Where could you be then? You have to be closer to A. You have to talk. This is the perpendicular bisector. Perpendicular. Can someone tell me? Yes, it's the right hand side. You have to be closer to A, no? So you can be anywhere on this side. Anywhere on the right hand side to this perpendicular bisector. You can be on the perpendicular bisector or anywhere on the right hand side of it. Then you would be closer to A than you are to B. Is this clear? Now this is the whole side of the whole thing here. Oh, sorry about that, Tarindu. Oh, Malik, explain again. Yeah, shall I just write this in words first? I think you didn't understand what this means in words. I will write here on this side. What this inequality says in words is this. I'm translating this into words. Distance from Z to A must be less than or equal to the distance from Z to B. In other words, that implies Z must be, if I combine it in just to like one simple sentence, it means Z must be, the equality tells me must be equidistant, can be equidistant to A and B, or Z must be, what is the, this sign tells me Z must be closer to A than to B. Now really think about the meaning of that and look at the diagram and see, then you will understand. I have shaded the region that satisfies what I have written here. You have to understand that meaning. I mean, it's just plain language, then you will understand it. Got it now? Yeah. So you are either on this line. You forgot whole distance thing. You can be anywhere on the perpendicular bisector line or to the right of it, where the side on which A is. Okay, Malik. Is that clear? We are not able to finish this today. Yeah, it took more time, longer than I thought for this this thing. We only have the last little topic. I thought we could do it today. Okay, shall I give you one more of this type? Number 20. Can I change the screen? Can I change the screen? Please write everything I have written here. There should be a little. Okay, Malia says okay. What's the number now? 28. Okay, number 28. Show me the region Okay, this one. Oh, make this minus. Okay, do this one. I'll give you 2 minutes, 3 minutes. Okay, how is it going? First thing, you need to change this. We don't have the proper format here. So we need to rewrite this. Z minus what number greater than, this side is okay. Z minus what number? I have 5 nicely here. What is this number? Let me write this also in red. And what is this number? This is going to be, and I will put it in A plus BI form. I purposely gave I first and then the imaginary plus real, right? It's going to be minus 4 minus 3i, isn't it? Minus 4 minus 3i, right? Let me call that A and let me call this B. Okay, minus 4 minus 3i. Oh, somewhere here. Say this is minus 4, it's minus 3i. So that would be right here. This is my A. Right? And my 5 would be somewhere here where 5 is. So that's my B. Now easy to think. Okay. First, draw the perpendicular bisector. Can you be on it? You can't be on it because you don't have the equal sign. So when you do the, I can't, I don't have that. You have to do it nice like that. You connect them and find the midpoint roughly. Where is it going to be? Somewhere here. And draw the perpendicular bisector. Draw the perpendicular bisector. It's not a solid line, it's a dotted line. And which side of it? You have to be closer to which point? Distance from A to U is greater than the distance from U to B. So you have to be closer to B. You have to be closer to B means you can be anywhere on that side. The whole right-hand side to the dotted line, to the perpendicular bisector. Did you get this? I have not labeled my axis. Did you understand? Do you understand this? The perpendicular bisector must be a dotted line and you have to shade everything on above it or onto the right of it. Okay. Oh, I'm so happy to hear that. Oh, I don't understand how you figure out which side, but I'll go through the note later and see if I can. Oh, Hatri. Hatri. It's Hatri, you have to be closer to B. B is on this side. You have to be closer to B, no, not than to A. So it's the side of B. Now take what you have to, just take any point somewhere here. Let me take some point here on the side where B is. In the you have the perpendicular bisector. On one side of it you have B. On one side you have A. Now, if you have to be closer to B, you have to be on the side where B is, isn't it? Take any point on that side. Between A and, because the distance between A and Z has to, that's correct, right? Take any point on this side. The distance from U to B would be smaller than the distance from U to A. If you take any point on this, for any point, you are closer to B than you are to A. Yeah, okay. Towards B, yes, from the bisector, the side where B is. Please translate this into words. Closer to B than to A. Very simple. Oops. Closer to B than to A. Z must be closer to B, closer to IO. What am I writing? And this is not working also. Closer to B than to A, correct? Instantly. Oh, I'm very happy. Malik, then only the length of A will greater than that of B. Length of A. Yes, that's right. Yes. Clear now? Okay. What I feel is this. You need some more practice, and what you have to master here is this conversion, converting the symbolic expression into meaning that your heart, you feel it. Oh, like it's so easy when you turn into words like that. Otherwise, this diagram is very abstract and it looks, what are you shading? But just bring it to something very real. Like think of that's why I took this tree example. Think of it's on land. There are two trees. If you should be closer to this tree than to that tree, like it's very easy to think like that. Okay. Okay. We are running out of time. I will send you a whole bunch. There is a whole exercise in the textbook to practice all these illustrating on the complex plane, all the complex numbers that satisfy a given condition,